So this video demonstrates the estimation of ferrous ion by potentiometric titration. So the apparatus required for the estimation titrations are the potentiometer. So the potentiometer has inbuilt magnetic stirrer, 2 electrodes. One is reference electrode, saturated calomel electrode. Another one is platinum indicator electrode. We can see the platinum foil inside, one burette, one pipette, one beaker, one funnel. And so the solutions needed for these titrations are this burette solution, potassium dichromate, it's a titrant, then analyte, the sample containing ferrous, dilute sulfuric acid, and deionized water. So fill up your burette after cleaning, washing, rinsing and everything with potassium dichromate and leave it in the stand. Next, you clean both the electrode using the deionized water. So just lift it up and spray like this all the side. So to clean the platinum foil inside, so we have to, there is a hole, we have to pour through the hole the water. Then remove the water sticking inside the electrode as well as outside by using the filter paper. So gently clean both the electrode and leave it for few seconds. Let all the water which is inside will come out. Then discard the solution in the beaker. So discard it, clean it, wash it and pipette out 20 ml of your ferrous sulfate solution. So I am going to make it acidic by adding 20 ml of dilute sulfuric acid. So we can add one big test tube full of dilute sulfuric acid and keep it in the potentiometer. So bring both the electrode inside the beaker and keep it just above the solution level. So I am going to stir the solution using the magnetic stirrer. So for that one we need the magnetic stirrer or stirring ball. So we clean it with deionized water nicely, then wipe it. Just drop it inside slowly and we can start the experiment. Switch it on your stirrer, adjust the beaker, so let it stir smoothly. So we can adjust, if you adjust properly the sound will be very less, so it won't spill any solution to the side of the beaker. So stir it for 30 seconds. So 30 seconds is only approximate timing, so no need to go for exact 30 seconds. After 30 seconds, you switch off the stirrer and wait for that stirring ball come to the rest. After that, bring both the electrode inside. So wait for the stable EMF reading potential. So during that one, what will happen inside the solution? Now the active ions is only Fe2 plus ion. So it moves towards your electrode and it forms an electrochemical double layer and develop potential at the platinum electrode. So that we are going to measure only equilibrium potential. Wait for the potential get stabilized. It may take 30 seconds to 1 minute. So if you within 30 seconds, if you find the value is constant for 5 seconds, more than 5 seconds, we can enter the value. So now the reading is almost stabilized, not much change. So if it is stable for more than 5 seconds, I can enter the reading. So now it is stable, it is 0.322. I can enter the reading in the observation notebook. So without addition of dioxidizing agent, we have to take first reading. Now lift the electrode just above the solution level. Bring the burette inside the beaker, keep it inside the beaker and add just 1 ml of your oxidizing agent. So the added chromium 6 plus is yellow in color. When we stir, so the chromium 6 plus react with Fe2 plus ion and oxidizes this Fe2 plus ion into Fe3 plus ions. Because of that one, the color of chromium 6 plus disappears and the yellow green color. So due to the formation of Fe3 plus appeared now. So light green color is coming now. We can see the light green color. So stir it for 30 seconds. Then switch it off. Switch off the stirrer and bring back both the electrode to the solution. So wait for the stable potential. Now that ion solution contain Fe2 plus, Fe3 plus and chromium 3 plus ions. They will form the electrochemical double layer or Helmholtz double layer at the platinum indicated electrode. So wait for the equilibrium potential. So it is almost stable. I can enter the reading now, 0.374. So we have to take reading. So 1 ml addition and enter in the observation notebook. So I have taken reading for up to 6 ml addition. So that is a slow increase in the EMF. The color also intensified. Now it become almost green. So indicate more amount of Fe3 plus in the solution. That means more amount of Fe2 plus is already oxidized into Fe3 plus ion. Now I am going to show the reading for the 7th ml addition. So switch it off after 30 seconds. So wait for the magnetic steering ball come to rest. Immerse both the electrode. So we can see still it is in the range of 500 knots. There is no, I couldn't observe any sudden increase in the reading. So it indicates still Fe2 plus is present in the solution, as well as this color is also only green color. It indicates Fe3 plus ions are there, as well as Fe2 plus ions are also there. So I am going to add another 1 more ml. Okay. We can stir the solution. So now we'll see that color change in the solution. So we can see along with your green color, one yellow shade is there. That means the chromium 6 plus added is not at all used by Fe2 plus ion. That means it does not contain Fe2 plus ion. All Fe2 plus ions are completely oxidized to Fe3 plus ion. We'll check, we'll confirm this one by EMF value. Yes, you can see how the reading is changing. There is a sharp increase. It is the 7th ml, we got only around 538 millivolt. But now it is around 690, around 700 millivolt. Almost more than, so also more than 150 millivolt increase is there. So it confirms that already we reached the equivalent point. I will wait for the stable reading. stable around 697. We can enter the reading now. So I will show one more reading. So we'll see what happens when you add excess addition of chromium 6 plus after equivalent point, whether the color will change or not. So of course it won't change, but the yellow color will be intensified because of excess addition of chromium 6 plus. You can see that yellow color is getting intensified, become dark and dark in yellow color, but still we can see the green color. So the Fe3 plus ion is still there. Besides, the excess chromium 6 plus is added to the solution, so it intensifies the yellow color of the solution. So we'll switch it off, take the reading. What will happen to the EMF value, potential of this experiment, that solution? You can see there is not much difference in the value. It is almost 0. It is 702. So there is not much change in the reading. So it is in the last 2 decimal only there is a change in the EMF value. So we'll have to take that reading for another 6 ml, more ml addition of chromium 6 plus and enter the value. So I'll take the reading now. So we have to enter the reading. So we have to take reading for another 6 ml addition and enter in your observation notebook. So in meantime, when you wait for that equilibrium and stirring, you can do the calculation as well. So we have other parameters like delta E, delta V, delta E by delta V and average volume. So once you take 2 reading, you can start calculating delta E and delta V and enter the reading. So for each 1 ml addition, we can take the reading and enter here. Before going for the calculation, so we have to clean both your electrodes. So the same way we have done before start your experiment. So we have to clean both the electrode. So you have to spray like this. Through the hole also you have to spray water and wipe it again with tissue paper. And you can discard the solution. So take the magnetic stirring ball inside from that beaker and clean the beaker with tap water, then deionized water, then fill up to 50 ml with deionized water and immerse both the electrode inside the water. So we cannot leave the electrode inside your solution for a long time, it will contaminate both the electrodes. So keep the magnetic stirrer inside the box container given to you. So now we can go with the calculation.